All right, so hello everyone. I hope everyone's having a great weekend till now. So we'd be discussing the Leetcode weekly solutions for today, the weekly contest solutions for today. The date when I'm recording this video is what's the date today? It's 10th of March. All right, and the time is 11 a.m. Just let's go to the contest. Let's just move on to the screen. All right. So, as usual, firstly, I'll be giving a general overview for the contest. The weekly contest number is 388. So, briefly talking about it, again, I would say the contest was more on the easy side. The first three problems were pretty easy. The final problem was a bit difficult, but still, it was doable as compared to the previous contest problems. So, let's get started with the solutions. All right. We are having four problems. You can check the marking scheme. 2, 4, 5, 6. So again, this is something which they change after every 4 or 5 contests, what I've seen. So yeah, today as well they have changed it a bit from 3 to 2. I don't know what reason behind that, but that is how it is. Okay. So let's get started with the contest discussions. Let's move on to the whiteboard. Okay. So we have weekly contest number 388. All right. Okay. Let's see the first problem. Apple redistribution into boxes. So we have been given an array apple of size n and an array capacity of size m. There are n packs where the ith pack contains apple of I number of apples. Okay. So the ith element of the apple array contains that many number of apples. There are m boxes as well where the capacity of the ith box is capacity of I. And capacity box, this capacity array, every element of the capacity array is actually a box which can store that many number of apples. All right, we need to return the minimum number of boxes. We need to select to redistribute these n packs of apples into boxes. All right, so we need to give the minimum number of boxes that would be required to store all the apples. Note that apples from the same pack can be redistributed into different boxes. So this point is very important. This means that, let's say if I have in total 50 apples, okay, so it's not like that the first element should be present completely in a single box, okay. If I want to accommodate them, then I can store half of the apples of the ith element in one box and the rest in the other box, okay. This is what they mean. So again, this is a fairly simple problem. All right. I hope everyone would have solved it, but I'll just quickly go through the discussion and then the code for this. Okay. Problem one. All right. We have apples array and we have capacity array. Okay. Yeah. So what we have to do is we take sum of apples. Okay. Sum of apples is equals to x. All right. And then we'll store these X apples in the boxes. So this is what we need to figure out, that what is the best possible way wherein I can store all these apples and I take the minimum number of boxes. So that would be that I'll start from the greatest element. Okay. I'll always try to pick the greatest size of the capacity array first. Okay. So let's say I kind of sort this. Okay. And I start from I is equals to m minus 1. Let's take the size of capacity array as m. So I start from m minus 1. Every time I'll subtract x minus equals to capacity of I. I'll do I minus minus. Okay. Whenever x is less than equal to 0, I break. Okay. And I know how many apples, how many boxes I've consumed now from the I variable. I can calculate it using this n minus 1 minus I. This is another way to do it. Okay. Or you can maintain a counter. Okay. So you can increment the counter as well every time. Okay, so this is another way. All right. Fairly simple problem. Okay. The complexity for this code would be uh, n log n. All right, because you'd need to sort the array. All right, capacity array. So that is where we'll have a this n log n complexity. Rest all the operations would be in O of n, simple for loops, but the worst case becomes n log n. We are not using any additional space, so the space complexity is O of 1. Okay, so let's see the code for this question. Okay, again, the size is very small as well. So this again kind of gives you an idea that we can even go for a brute force solution for this. But then again, the sorting based solution is the most optimal and the most, what do you say, as the usual solution which would strike your mind first. Okay, so again, this is what I'm doing. I'm sorting my capacity array in the reverse order this time. Okay, I've maintained a sum variable, I've maintained my I variable, all right, and yeah, now again that is sorted in the reverse order, so I can traverse from the beginning. So firstly I'll take the sum of all my apples, okay, in the sum variable. Then I'll start iterating on the capacity array. While the sum is greater than 0, I'll do sum minus equal capacity of I. And again, when the sum would become less than equal to 0, automatically the loop will break. And you can simply just return the I variable then because you have declared it here globally. All right. So this can be used. So yeah, if you submit this one, it'll get accepted, and it was a fairly simple problem. I hope everyone would have solved this. Okay. Let's move on to the next question. So we have been given an array happiness of length n and a positive integer k. There are n children standing in a queue where the ith child has happiness value, happiness of I. You want to select k children from these n children in k turns. Okay. We need to select k children from n children in total in k turns. Okay. So in every turn we are selecting one child. In each turn you select a child, the happiness of that child that has not been selected till now decreases by 1. Okay, so let's say in the ith, we have k operations in total. So in the ith operation, if I select a particular child, so all the other children who have not been selected yet, for them the happiness value will decrease by 1. Okay, note that the happiness value cannot become negative and gets decremented only if it is positive. Okay, so again, this is just signifying that it cannot be less than 0. So let's say it at a particular instance, if a happiness value for some element which is not selected is 0, so I cannot decrease it to -1. It will remain at 0 only. Okay, I need to return the maximum sum of happiness values of the selected children I can achieve by selecting k children. Okay, you need to return the maximum value. Okay, so let's see the whiteboard. This again is kind of a simple problem. Okay, we'd be using priority queue or a set data structure for this, but I think priority queue would be much more easier to implement. Okay, so I have taken that solution. Okay. See, it's very important in the contest that even if you have more than one approaches, you are able to select that which one would require less coding effort. Because in these kind of contests, specifically for these problems, which are the easier ones, it is important that you solve them and you solve them quickly so that you get a decent rank. Okay. So we have happiness array. I'm naming it as HAP at the moment. Okay. What I'll do is if you need to select uh, or every element once. Okay, you need to select one element every time from all the values, and you need to have the maximum strength value. So in that case, ideal solution would be that you always pick the greatest value from the happiness array. Okay, so firstly I'll prepare a priority queue. Okay, and this will be a max heap. Okay, this will be a max heap, that is the maximum element will be at the top. Okay, so let's say this is our priority queue, PQ. Okay, I always like to name it as PQ. I don't know why. So yeah, we'll push all the elements. Okay, PQ dot push. I'm kind of writing the pseudo code, so you can again write the exact code. We'll discuss this as well, the exact code for this. Okay, yeah, here I've pushed all the elements of the happiness array. Okay, now I just need to kind of write a while loop, or you can go for a for loop as well. Till this k value is greater than 0, you pick the pq dot top. Okay, this is your top element. Okay, now this value has to change. What will be the actual value? This is what is stored in the array. Okay, you see, if before this there were z number of operations that had taken place before this this actual operation if they were Z operations. So this actually had to be X minus Z. No, we discussed that the value has to be decremented every time if it is not selected, the rest of the values, right? So where is the eraser? Yeah, here it is. Okay. So this is what you need to do, all right? And for that you need to maintain a counter as well here. So I'll declare a counter Z here, okay, which is initialized by 0, okay. I'll change it to max value of 0 comma x minus z, because it could be a possibility that x minus z is negative and I don't want negative values, okay. So this is what I've done. Again, I'll declare say an answer variable which will store the sum, okay. I'll add answer every time. I'll add x every time to answer, and I'll do z plus plus for the number of operations, okay. And when I come out, I just return answer, okay. That's it. So this is all we are doing. The complexity for this solution is n log n, where n, sorry, not n log n, wait a minute. Where it will be k, no, wait a minute, let me think about it. O of n here, okay. Push the elements, yeah, that will be n log n only. N log n, okay. Why? For pushing all these elements, okay. This will be the worst case scenario where n is the size of the happiness array. So n log n, n for traversing over the happiness array, and log n complexity for pushing every element to the priority queue. So that encounters n log n complexity. So overall it becomes n log n. Space complexity, again, it would be O of n for the priority queue. Yeah, that will be the space complexity. Okay, all right. So let's see the code for this. Okay. Yeah, the size is 10 power 5. So again, from this also you can uh, deduct that we have to go for a better solution, an optimized solution, that is a priority queue or a set based solution. Okay. So I declare my priority queue. I push all my elements in the priority queue. I declare my answer variable. I declare my decrement variable. I write the while loop. I pick up the top element. Okay. I update that element. All right. I add it to my answer, and I increase the decrement as well. And once this value would be 0, we'll break out of the loop and I'll return my answer. Okay. So this will get accepted again. If you check it, this will get accepted. Okay. So yeah, let's move on to the next question. The third question for today. That is, we have been given an array of size n n consisting of non-empty strings. Okay. We need to find a string array answer of size n such that answer of I is the shortest substring of array of I that does not occur as a substring in any other element of the ARR. Okay, so for the ith element, we need to pick such a substring from the given ith substring that that particular substring should not appear in any other this thing, any other element. Okay, it should not appear as a substring in any other string of the array. All right, this is what we need to tell, and we need to pick the shortest substring as well. And let's say if there is two substrings of the same length, then you'll return the lexicographically smallest one. So I hope everyone's aware of what lexicographically smallest is. In simple terms, you can understand this as the alphabetically smallest string. Okay, in the dictionary order. Okay, just a small hack to remember that. Always think about the dictionary order when it comes to lexicographicity. Okay. And we need to return the array answer. Okay. So let's see the constraints for this. So on the first go, this question seems like a very difficult one because you need to tell all the substrings. So it could be a possibility that you think about that KMP algorithm and all that. But once you see the constraints, okay, so the constraints are very small here. That means you can easily go for a brute force solution. And the only catch for this question was to solve it in the first go and to solve it quickly. Because as I said, this question would require a hell lot of coding effort. It requires more code written. The approach is very simple, but you need to write more code and you need to write it correct in the first go. Because for these kind of questions, what happens is you have the approach as crystal clear in your mind, but when you start writing it in the pressure of the contest duration, you end up writing wrong solutions or not covering all the cases at the first go. Okay. So let's discuss the approach for this. Okay, let's keep it simple because we can go for a brute force solution. So I'd like to discuss the exact brute force approach for this. Okay, and that can be something which can be coded easily. Okay, so we need to check all the substrings. Okay, so and you have small constraints. So it is very easy to store the substrings of all the elements of the array. Okay, let's say these are these strings. So I can, for every element, I can get all substrings. Okay, it's very easy to get this thing. Okay, so you firstly, for all the elements, you store all the substrings in a mapped data structure with the frequency. So it will be like our map would be, okay, string comma int. Int stores the frequency. That is the first thing. Another thing which you need to store is a 2D array of strings. Okay, 2D vector. I'll go for a vector again. It's easier to do. Okay. So str, I'm writing it in short form here. Okay. Subs, let's name it subs only. Okay. So subs of I, subs will be of size same as that of this original array. Okay. So subs of I will store all the substrings for the ith element. Okay. So for this element, all the substrings, let's say, will be stored here. Okay. This is what we are storing, and we will sort it as well because we need to return the lexicographically smallest one. Okay. So you sort every this thing subs of I. Okay. This is also needed. All right. You have sorted it as well. Now you have all the substrings, you have all their frequencies, you have all of them sorted. All you need to check now is that why do we keep the frequency? Okay, let's discuss that. Why are we keeping the frequency? Because in this array, once it is sorted, if you check the ith element of this array, you want to check if its frequency is 1 or not. If the frequency is 1, that means it is not occurring as a substring in any other string. Okay, so you can have that as answered that time only. Bullseye. That ends the question. Okay, that is how we do it. All right. We just store all the substrings, we sort them, we store the frequencies of all the substrings, and for those strings which have a frequency of 1, those can be our possible answers based on the rest of conditions that whether they are lexicographically smallest or not. Okay. So yeah, this is how we'll be doing it. Again, this for this question I'd like to give a complexity part as a homework. Okay. Although it's pretty simple, like the space complexity would somewhat be n square. Not n square, it would be O of n into L, where L is the maximum length possible, n is the size, so this would be the space complexity. Time complexity, I'd like you guys to work out on your own. Else you can post your comments in the chat section if you want me to discuss it. Okay. So let's move on to the code for this question. Okay. Again, as I said, the code would be a long one. Okay. So this is our answer string array. This is our that what do you call a substring array, and this is our map which stores the frequency. So again, I iterate over the ith element of the original array. I take its size. Herein, I am calculating the substring. See, this I'm adding the substring every time. Okay. I'm checking if it is found already. If it is already present somewhere, then I'm not including it. Okay. So you can avoid this step as well. If you don't want to get it complex, if you want, you can avoid this step. Okay. So, and if you avoid this thing, or even if you don't, then the code remains the same rest of. You add that substring to the map, you increase the frequency, and you push it to the substring of I element. Okay, that is, it is the substring for the ith element. And after coming out of this loop, you sort the substring of I. All right. Now the only approach left is for the ith element, you check all its substrings and you check if the frequency is 1. If it is, you mark it as the answer and you break out of the loop. Okay. By default, if you see, I've marked all the answers to be the empty substrings because this is what they have asked in the question that uh, if no substring exists, answer I should be an empty string. Okay. So that is why I marked it as an empty one. All right. So this finishes the third problem. Let's move on to the final problem. Okay, a decently good problem. If you guys are comfortable with dynamic programming on that memoization DP, recursive DP, then you can easily solve this problem. Okay, so this is the good thing about DP problems, that when you get DP problems as the final question, okay, and if you have practiced enough number of questions of recursive dynamic programming, in 95% cases I have observed that the students are able to come up with a solution. Okay, so that is why DP is very important, because say if I have a graph question here, in case of graphs or in, you still have the case wherein you can get a stupid question discussing some very complex algorithm which you have not studied. Okay, and at the time in the duration of the contest, of course, if you do not know the algorithm, you might not be able to come up with a optimal solution. Okay, so that is why DP problems are very useful. That is why teachers as well, and in the even the companies pay so much attention to the fact that whether the students can solve the DP problems or not, because these kind of problems actually test your problem solving skills. Okay, so let's get started with this question. Give me a minute. All right, so we have been given a zero index integer array nums of length n and a positive integer k. The strength of x subarrays is defined as sum of 1x minus sum of 2x minus 1 plus sum of 3x minus 2. Okay, so they have given some operation, and they have given the general term for this expression. Formally, the strength, here I am reading, formally the strength in sum, strength is sum of minus 1 to the power I plus 1, sum of I, x minus I plus 1. So this is the actual value of the ith element. Okay, you put the value of I and you get this value in place. Okay, for all I such that I is between 1 to x, you need to select k disjoint subarrays from nums such that the strength is maximum. Return the maximum possible strength that can be obtained. Note that you note that the selected subarrays don't need to cover the entire array. So we need not cover the entire array, but the subarrays we select, those should be the disjoint ones. Disjoint means that they should not have any element in common, two subarrays. Okay, so yeah, this is what we have to discuss now. All right, and let's get started with the approach. Okay, all right. Okay, let's discuss this. Problem 4. So I'll give you an insight into this, how I'm arriving on a DP1. Okay. Of course, you see, what do we firstly check in the DP problems? That whether we can have more than one solutions. Okay, uh, right? This is what we need to check, and this is what is here, because you do not know optimally which element to select and which to not. Okay, so the two cases for any element would come out to be either you select it or you reject it. Okay, select it or reject it. So if you reject it, okay, what will you do? Ideally, let's say if I am at the ith element, okay, and I have covered k number of subarrays, this is the number of subarrays that is left. So if I want to leave this element, I'll simply go to I plus 1 k, right? Simple as that. I need not make any changes to my k variable. Okay, now let's come to the case wherein I want to select the element. Okay, so here are two possible cases. Okay, that is I am selecting this element and I am continuing this. That is, it is somewhere in the middle of my this thing, sub array. That is, it's somewhere here. This element is somewhere here. That means more elements will come forward. Another case is that it is the end or it is the beginning. No, not the beginning. It is the end. Okay, that means it is the last element. So in that case, I'll do I plus 1 k minus 1. Okay, k minus 1. This is very important because I'm starting from k as the maximum value. So I'll decrement whenever I reach the case that I am ending any of the subarrays. Okay, so this is the possibility. And that's it. That is all you have for dynamic programming. These are the two variables which you need to take care of. Another variable which will come into picture, I'll signify that. Again, that you can do it, what do you call as, by some other mathematical approach, but let's discuss it. So that variable would be the this thing, what do you call as, odd or even. Okay, you need to check the subarray which you are selecting, whether it's an odd number subarray or it's an even number. Why we are doing that? Okay, please check the problem constraints. They have given k is odd. Why have they given that condition? They have given it because, let's say, the odd elements will always get added and the neg even ones will always get subtracted. Okay, you see the minus sign for all the even one because this is the second one. Similarly, the fourth one. Okay, so this is why we need that. So if it's an odd one, okay, odd or even one, whatever it is, this case would still remain the same. This case would change. Okay. In case of odd, you'll try to add the value, and in case of even, you'll try to subtract those values. Okay. The only sign which you'll do is the only change you will make is of this addition sign or the subtraction sign. That's all. Okay. So let's quickly move on to the code for it. Again, we'll go for a recursive approach for this. So let's go through the code quickly. Okay, I create an answer variable. I create n for the size. Okay, I've declared my DP for storing the values n, k. What I'm storing ith index. So the maximum value of I can be n. So I've taken the size to be n plus 1. Similarly, the number of disjoint subarrays k plus 1. Vector long int 3 comma minus 1. Pretty simple. This is for storing the boolean, whether it is odd or even and all that. Okay. And now you go for the actual solution, the DP based solution for this. Okay. So yeah, let's get started with the code. Okay, so I have taken two operations. This would be the odd one, this would be the even one. I initially check if the subarray I'm selecting, that's an odd one or the even one. Okay, if I'm trying to skip it, okay, so you need to store the boolean for skip as well, whether you are skipping an element or not, whether you are looking forward to skipping the element or not. This is also what you need to store. Okay, so this is the boolean for that skip. All right. So yeah, if you're skipping it, then I said the approach is pretty simple. You just go get answer I plus 1, don't change k value, and the skip variable remains same because it could be a possibility that you still decide to skip the next element as well. Okay, right? Another operation is if x is equals to 1, that is if x is odd now. So you want to select some element, let's say. What you will do is you will select this element. For odd, you will add it to the answer. Okay. And if you have added it to the answer, okay, you do I plus 1 and you do not decrement k because this is somewhere in the middle. Okay. Nums of I into k, this is what you will add. Okay. Okay, sum of 1 into x. So if there are, let's say k is some element in between, so it would get multiplied by x only, right? And this is what I'm doing here. I'm multiplying it by the number k. Okay. Next, next operation possible is that you do I plus 1 and you decrement the k variable. That is, this is the last element now. Okay, so you will have to decrement the k variable and you might just have to skip the next element as well. So that is why you are adding it to 1. Because if you do not, if you see if this is a continuous element, okay, if there's somewhere in between, then you cannot skip the next element after it. So you need to mark s as 0, else you need to mark s as 1. Okay, this for the odd case, and for the even case the operation would remain same. The only difference will be between the negative sign. This is all you have. All right. And finally, you add it to your DP and you return the maximum value of op1, comma op2. Okay. Base cases would be that if k is less than 0 at any instance, you return minus 1 E18. Okay. Because you need to return a very small value for that. If I is equals to n, that is, we have reached the end of the array. So if k is equal to 0, only then you can return 0, else you'll have to return this negative value only. Okay, and this is again our memoization step wherein I'm checking if the value is already present, so I just return that value. Okay, this is what I'm say, checking. Once you submit this, you'll get full marks for this code as well. And yeah, so let's do a final overview for the contest. Okay, problem 1, problem 2, problem 3, problem 4. I would say that today's contest was again fairly simple as similar to the last contest as well. Last one was so very simple, but this one was still a bit difficult as compared to that, but easier as compared to the previous contest we have observed in the last 2 months. Okay, so this question, these three questions should have been solved in not more than 15 to 20 minutes. Okay. And the final problem again depends on how well you are at DP. But if you were able to pick up the DP, then you could have solved it in not more than 30 minutes. 30 is the upper limit I'm taking for this question. So in today's contest, we could have easily solved all the four questions. And yeah, this is what my review for this contest is. And yes, let's end the discussion for today. I hope everyone found this session to be useful. Please share these videos with your friends and people in need, juniors and all that. So that I get motivated to make more such videos. And yeah, let's meet for the next week for the upcoming contests. Have a great weekend, everyone. Bye bye.